Okay, today we're going to work on 8.5 task for Math 1 Honors. We're going to be talking about correlation coefficients, linear regression, line of best fit, and sort of using the line of best fit to predict future information, future data. So we start with this situation where each year the U.S. Census Bureau provides income statistics for the United States. And the data in the tables below show the median income for each year since 1990 for each gender. So all the dollar amounts have been adjusted for the rate of inflation so that they are comparable from year to year. So here you have a table. It has years 1990 all the way through 2005. The median income for men starting at 38,000 going to 41,000. Here you have a table showing all the years from 1990 to 2005 with their median income starting at 18,000, ending with 23,000. So the first direction actually tells us to create a scatter plot of the data for the men on the provided graph. So I've done that over here in Desmos. Zoom in a little bit. So I just went ahead and put this table into Desmos and had it graph my scatter plot for me. So when you look at that, thinking about what you learned in 8.4, how well would you say that data is correlated? So if you had to guess the correlation coefficient for that data, what would you guess? And it's obviously not 1, but it is, if you had to say that it's a slope, it sort of goes in the positive direction, but not all the dots are on, on the exact line. So it's pretty highly correlated, I would say. So maybe I would estimate 0.8, let's say. And how about I write my answers in red, and then you can see them a little better. Okay. So actually using technology, you want to go ahead and find the correlation coefficient. So we'll go over here and use Desmos to get the linear regression and get some information. So since I'm using this table, which is x sub 1, y sub 1, I'm going to go ahead and use, I want to see y equals mx plus b, right, for my line. So I have y sub 1 equals m x sub 1 plus b. And I'm just telling it to use this table and give me a line. So you see here it graphed a line. I'm going to make it green. Okay, so it gave me my correlation coefficient, which is actually 0.7928. So 0.7928, which is about really close to almost 8, right? So that's pretty high. I estimated 8, and it was really close. So what does the correlation coefficient tell you about the relationship between the median income and the year for men? So, I mean, I can answer that in terms of math. Like, what does it mean math-wise? I would say it's a strong, positive correlation. It's linear, right? Like, it's not exponential or anything. And then if I wanted to say, in context, since it has a strong positive correlation, I would say as the years, which is x, pass, the median income increases. So the median income being y, you can see as x increases, y increases for the most part. It goes down a little bit here, but for the most part it increases. And what is the linear regression equation for men? Well, the linear regression equation is given to us because we know the slope, we know the y-intercept. So I can go ahead and write my equation. Y equals, I don't know why I made capital a little bit. Okay, so y equals M, which is 311.661 x plus 37629.7. So next thing is to create a scatter plot using a different color of the data for women on the same graph. So here I went and put that information from the table into Desmos, and it went ahead and made a scatter plot for me for the women. And so it says, what is your estimate of the correlation coefficient for these data? Well, when you look at this data, it looks even more closely correlated or positively correlated than this men's data, right? Because the men sort of went as a jump and then came back down. So if I had to draw a straight line through this data, it's even closer. So I'm going to just guess, maybe I'd estimate 0.9. 0.9, really close to 1. So if I want to use technology to find that correlation coefficient, I can go ahead and just put into Desmos, what's the line of best fit for this table. So now that I'm using x sub 2, y sub 2 table, I want to go ahead and use y sub 2 equals m x sub 2 plus b. So I get a bunch of information here. So I have the correlation coefficient here, which is R, really, really high, right? 0.9676, almost 1, almost perfect, right? Because 1 would be a perfectly straight line. Look how many dots you have on that line. I'm going to go ahead and make it red. If I can. Make it red. Okay. So what does the correlation coefficient tell you about the relationship between median income and the year for women? So if I wanted to talk in like math-wise, I would say a very strong positive correlation, positive maybe linear correlation. And then in terms of context, let's say as the years, which is our x, right, pass or increase, the median income, which is our y, increases. And I'm just going to add say steadily, because it's almost has a almost 1, right? So it's very steady that it increases. So what is the linear regression for women? Well, I can get that from Desmos over here. Go back over here, get my color situation. Okay, I have the slope of the y-intercept, so I can go ahead and write my equation down here. So y equals m, which is 460.886 x plus 18,018.3. And how do the two data sets compare? So now it's especially helpful because we have them both on the same graph, right? So how do they compare? Well, it looks like, you have different slopes. So you have one growing faster than the other. You can see that the women's line of best fit is steeper, and you can see that in their equations also. Slope is different. Okay, so, but it's actually asks how do the data sets compare? Well, the men's starts higher, right? Men's median income starts higher. You can see that in the y-intercept. But we can talk about that later. So the men's income starts higher, but it increases at a slower rate. And you can see that in the graph. You can see that in the equation too, but you can see it even more clearly in the graph. So what does the slope mean in each case? Well, slope is average rise. So average rise of income, well, median income by a year And for the men, you have $311 per year raise. And for the women, you can see that they have a $464 raise per year. So you can see that the women's, just like in number 3, we said the women's rates increase higher. And then faster. So what does the y-intercept mean in each case? Well, the y-intercept means the starting median income in 1990. So for the men, that's $37,629. And for the women, that's $18,640. $18,018.3. So notice that we're not taking this information from the table. We're actually taking it from our equation. So I thought it was just interesting to note that the women's income was only 47% of the men's income. Not that that was asked, but I thought it was interesting. Okay, so compare the regression model for men and women. What do the models tell us about the income of men versus women in the years from 1991 to 2005? So women, you're just trying to compare them. So women start, it does ask that, with an income 47% of men's starting income, but the women's income increases faster than the men's from 1991 to 2005. What do you estimate will be the median income for men and women in 2015? So remember, X represents the year since 1990. So use the linear regression model to check your estimate. So this you probably want to work out in your notebook as far as showing work to use an equation. So for the men, remember your equation was y equals 311.6, and then it actually says, what do you estimate the median income for men and women in 2015? So what is really 2015? What am I using for 2015 instead of 2015? I want to say, well, that's 25 years from 1990, right? So that's what we're really looking for. Is I'm looking for 25 years from 1990. That's really what it's asking. So in here for X, instead of putting 2015, I just want to put 25 X plus 37,629. So this equals about 45,419. So if I'm using this linear regression model to predict future data, I would say that in 10 more years, so after 2005, so if it keeps growing in the same way, then if it keeps growing by $311.60 for 25 years, then men in 2015 are going to make about $45,419 median income. Okay, so for women, I just want to go ahead and use their linear regression model. So that was 464x, but instead of x, I'm going to put 25 plus 18,052. Is that 052? 18,052. it 1805 too? Let's see, 18018. 18018. 18018.3. Okay. So that's going to be approximately, if theirs keeps growing at the same rate, then they're going to make approximately $29,652 in 2015. So even though it said, what do you estimate, we actually use the linear regression model to check it, to figure it out. So the Census Bureau provided the following statistics now for the years from 2006 to 2011. So this is like extending the table that we started with, extending it all the way out to 2011. So you can see the men's income still, listed here, but notice that it's going down. And the women's income from 2006 to 2011 is actually staying pretty steady. So I went ahead and put that, it says add the following data to the graph using the appropriate color. Using the graph, what would you estimate the median income of men and women in 2015 to be, and why? So now we're going to go look at this. I went ahead and have this other graph where I can, I extended the table to all the way out to 2011. You can see that's 21 years after 1990. And I just put men here, women here, just to make, just a single table. So you see they're both graphed right here. And now I sort of want to know what's the new linear regression for all of the data from 2005 all the way, or from 1990 all the way to 2011. So I'm going to go ahead and figure that out for y sub 1. So y sub 1 equals m x sub 1 plus b. So now I have a new linear regression model. So the new, I'll write in red so you can see it better. Okay, so the new linear regression model for men is actually y equals 45.1182 x plus 39,378.5, and the new linear regression model, or the line of best fit, whatever, for women is y. Oh, we have to put that in. Go ahead and use y sub 2 down here. So y sub 2 equals m x sub 2 plus b. Okay, so for women, it's y equals negative. Do this. Like I did something wrong. Let me go back and try this again. It doesn't look negative, does it? All right, is that an expression? Okay, so y sub 2 is, I want this information over here, equals m x sub 2 plus b. All right, so we actually have y equals negative. Where did I start it? Y equals negative 16939.5 x plus 39378.5. So that's interesting. Why is it graphing it for me? Something. Oh, you know why? Because I used x sub 2. That's wrong. Okay, let's fix this. Sorry about that. I was thinking it doesn't look negative. All right, so actually we have y equals 300.7 458x plus 19,130.6. Okay. And then we can see that it's a positive also. So using the graph, what would you now estimate the median income of men and women in 2015 to be? So now this table only goes up to 2011. So now we can actually go ahead and use the new linear regression models because it has more data, so it's probably more accurate. So you have, for men, we'd have y equals 45.1182. And then what am I going to use for x now? So I have 26, 27, 28, 29, 30, 31, right? 31 years since 1990 plus 39,378.5. So that is approximately, figure it out. Calculator, I didn't have that one figured out. So 300 point, let's see, 45.1182 times 31 plus 39,378.5. So if it keeps increasing at that same rate, it should be about 40,777.16. In 2000, estimated in 2015, that's a lot lower than we had before. Okay, for women, it'd be y equals 300.758 times 31, 31 years since 1990, plus 19,130.6 equals, let's see, so 300.758 times 31, oops, 300.758 times 31 plus her starting income. So 28,454.10 dollars. Okay, so if we're using this new model, actually it says that these will be the estimates for 2015. So it's interesting because this it says how appropriate is the original linear regression model for men's and women's income, but beyond 2015. So actually, if we look at what you could do to answer that question is actually use the original equations and test it with these numbers. Like instead of figuring out what it is in 2015, you could figure out, oh, well, what if I put in 17? You know, what if I test this equation, but instead of putting in 25, I put in 17 and then 18 and 19. Then you can see if these really follow the original model. So it looks like it's actually not very appropriate, right? Because if I used my original data and I had my linear regression line, remember it had a positive, pretty strong positive slope, but now the men's started decreasing and the women's started decreasing also. So actually the original linear regression was not very appropriate. So the original, I'll write it in red. Original linear regression model was not appropriate. Not appropriate. Not appropriate. Because the original model had a positive slope, but From the graph and the table, you can see that the new incomes for men and women decline slightly from years 16 to 21 after 1990. So if you look at this model, you can see that actually, zoom in a little bit. Actually, they have a positive slope, and then negative. They actually have a negative slope. They go positive, positive, and then a negative slope. So interesting. What do you think happened? Makes you wonder what happened in this year, 2005 to 2006, that would cause median incomes for men and women to decline. So maybe you need to think about that in terms of what you've learned in history. What happened between 2005 2006 that would cause median incomes to go down? All right, well, I hope that helps you with completing your 8.5 Desmos or your 8.5 module, and hope you guys have a good day.